So what we do is we look at a closed basin first. Just a closed basin, where the fluid depth, okay, the water depth, the total water depth is capital H. We know what it is, okay? Doesn't matter. Yeah, we also know the length, okay? We know the length as well. Depth and length we know. So now there is a natural oscillation in this basin in which only the ends move up and down. When one is up, the other one is down. And you only have horizontal movement in the middle, and there's a node in the middle. Okay, it looks like this, on both sides up and down. Can't do it all together, but maybe if I do don't be silly, okay. This is called a sage. It's a natural oscillation. And you can work out exactly for a given period. So we're talking about tides, we know what the period is. You can exactly work out for a given height what length do you need in order to create this natural oscillation. Okay, and this one is known as Marian's formula. Okay, and it's written here, it's a little formula where essentially you have water depth in there, total water depth. You have the period, okay, and you have an n as the number of nodes that you want to create. Okay? And then it returns you the length that you need. Number of node means how many of these crossings do you want to have. This one is only one node, but you can also imagine you have a situation with two nodes. And two nodes would be a situation where both ends move up and down the same way, and in the middle opposite to either ends. Okay, two nodes, and you have two nodes where the water actually moves like this. All right, I practice this, believe me, I practice this. And you can see it's that half the wavelength fits into this basin. This is only half a wavelength. You go from one wave crest to one wave trough. Okay, that's why you have divided by 2 in here, in this form. Okay, so now what happens if you have not a closed basin, but a semi-enclosed basin? So what we do, we snip and remove the left boundary and just have the entrance of your estuary, or the mouth of your estuary mouth is here. Now you have the ocean tide. Okay, so now in this case of natural oscillation, you get the same thing if now the ocean tide excites the wave at the entrance, and what you get is you get pretty much no tide in the center, okay, but you get maximum tidal signal at the end. Okay, sorry, I'm a little bit blurry again, so I stop this part.